We're going to take a look at a Leetcode problem called robot bounded in circle. So given or on a infinite plane, a robot initially stands at 0, 0 and faces north. So the robot can receive one of the three instructions. So G basically goes straight 1 unit, L basically turn left 90 degree, R basically turn right 90 degree. So the robot performs the instructions given in order and repeats them forever. So basically we're given a string, right, that has a length between 1 to 100, and for each and every single character in the string is either G, L, or right, which is defined here. We want to return a Boolean true. We want to return true if there's a circle in the plane such that the robot will never leaves the circle, right? So after this instruction, right, it doesn't matter if we repeat the instruction 1 time, 2 times, and many of times, right? We want to check to see if the robot will never leave the circle or not, right? So let's take a look at an example. Here you can see we have our example, right? So this is our input string, and then we have a plane, we have an infinite plane. Doesn't matter which direction the robot is pointing to right now. Basically, let's say the robot is pointing to straight, right? So it's pointing to the straight direction. In this case, you can see if I will go straight one unit, right? So I will go here, then I will go here, right? So GG, let's go 2 units, and then I turn left 90 degree. So then I have the robot turning this way, and then I turn left one more time, and I have my robot turning this way, right? And then I go one more time, and I go twice. In this case, you can see the robot end up at the same position as before. So therefore, we're returning true as the output, right? And let's say we have another example where, let's say I only have go and go, right? So in this case, I go once, I go twice. In this case, you can see there's no way, right, for us to go back to the original position, right, which is 0, 0, right? In this case, you can see we'll keep going up, right? If I repeat this instruction, it will continue to go up, right? So therefore, there's no way for the robot to end up at the same position as before, or same position as the origin. And now let's say we have another example where we have go and left, right? So let's say we go go 1 unit, which is right here, right? We're pointing at this direction, and then we're going to the left. In this case, we're pointing left right now, and then we repeat this instruction one more time. So you can see we go once, and then we turn left. In this case, we have robot pointing to here. And now let's say we go one more time. In this case, we're here, and then we are pointing left. In this case, left is right here, right? And then now if we were to go one more time, in this case, I will go here, and I point left. In this case, is right here, right? So you can see that after we repeat this instruction 4 times, we end up at the same position as before, okay? And now let's say we have another example, right? You can see here, you will start to notice the pattern here. So let's say we have another example, right? Let's say we have go, right? We end up here and we turn left, which is right here. And then we go, and then we turn left. In this case, we're turning left, and then our arrow is pointing right here, right? And then I continue to go, and I turn the arrow right here. You can see. And then I go one more time, right? 1, 2, and I turn the arrow right here. It doesn't matter which arrow you're pointing to when you add the original, but you can see that after I repeat this instruction 4 times, I still be able to get the robot basically loop back to the original position, right? So you can see that basically we're checking to see if there's a cycle, right? And now let's say we have another example, right? You can see here. GGLL, right? So let's say we go, and then we turn, and then you can see that the robot was turning to here, and then I continue go, and I turn this robot left, which is basically 180 degree. So first it goes 2 steps forward and 2 steps backward, pretty much, right? So we basically repeat this instruction 2 times, and then we are able to get the robot pointing back or loop back to the original position, right? So now let's say we have another example, right? So let's say we have go, left, right? So let's say if I go, in this case, I go, and then I turn left one more, 2, 3, right? I turn left 3 times, and I continue to go, and I turn left 3 times, right? So in this case, I turn left, which is here, 2, and 3, right? And then in this case, you can see I can continue, right? I go, and then I turn left 3 times. So you can see here, I turn left, left, left 3 times, and I continue to go. And I turn left 3 times, but it doesn't really matter because you can see here, like we're basically end up at the same position, right? So I can basically repeat this instruction 4 times, and then we can still be able to end up at the same position, right? And now lastly, you can see here, like let's say we have another example like this, right? In this case, I start here, I go. In this case, I turn left 4 times, which is basically at the same position, and I can continue to go and turn the robot 4 times. In this case, you can see that after I turn the robot 4 times, I basically turn the robot 360 degrees, which is same direction as before. So you can see that this will give us false, right? Because you can see that the robots will continue to move forward, right? But however, though, you can see, let's say we have GLG, right? If we go and I turn left and then I go, right? In this case, I turn left and then I continue and I go, right? And then I go and I turn left and then I go and then I go and I turn left and then I go and then I go and then I turn left and then I go, right? You can see that basically we repeat this instruction 4 times, and at the end, this robot will still end up at the same position. What we can say is this, right? So if the initial direction does not equal to the result direction, then we can return true. And you can see here, because right here, right, if the initial direction, which is pointing to up, and then the result direction is still up, then you can see that there's no way that there will be a cycle, right? There's no way that the robot can return back to the original position. But in this case, just like before, if we loop through and then we end up the direction, right? So in this case, if I go and I turn left and then I go, in this case, you can see the result direction is left, right? And then there must be, right? In this case, if the result direction is not equal to the end direction, then we can pretty much return true. But we must pay attention to this, right? Like the result position must change. Because if the result position didn't change, right, if I'm like right here, right, and I'm just like changing one position, right, if I'm just like this, right, I should still return true because I'm still at the same position as before. So in this case, we must make sure that this condition is true if this condition is true, right? If the result position is changed and the initial direction does not equal to the result direction, then we can return true. But however, though, there could be a situation like this, right? Let's say we go, right? And then we turn left. And then we turn right. And then I turn left, right? And then I go. And then I turn left and I turn left. You can see that I'm end up at the same position as before. So should I return false? In this case, I shouldn't, right? Turn true. And same thing here. I can just turn left, and then right, and you can see that I'm still returning true because I'm still at the same position. So what we conclude is this, right? So if the initial direction does not equal to the result direction and the result direction changed, right, then we return true. If the result direction or the result position, right, didn't change, then we return true because I could just be like staying at this same position, just moving the pointers around, right? And then I'm still like not moving forward. I'm just basically changing the directions, and the end result or the output should return true, right? Now, if those conditions doesn't satisfy, then we have to return false, right? So now let's take a look at the code. So the code, basically what I did is I have our original position, right? This is our original position, which we have our original position pointing up. We have our up, left, down, and right in integer value. And then we also have our position, right? We want to make sure we keep track of our current position, right? The base case, or in this case, the final case is that if the current position, right, the result position changed, or in this case, if the result position didn't change, then we want to return true. If the result position changed, then we want to return false, right? So now let's take a look at the code. So the code, basically what I did is I have our original position, right? This is our original position, which we have our original position pointing up. We have our up, left, down, and right in integer value. And then we also have our position, right? We want to make sure we keep track of our current position, right? The base case, or in this case, the final case is that if the current position, right, the result position changed, or in this case, if the result position didn't change, then we want to return true. If the result position changed, but the current direction does not equal to the original direction, then we can return true. Otherwise, we can just return false, right? So this is what I did. I iterate each and every single character that we have in the instruction. So if it's a go, we basically move forward, right? But in this case, we want to make sure we move forward with the current direction. So if our current direction is up, we will decrease the row by 1, just like how we traverse 2D array, right? If it's down, we basically increase row by 1. If it's left, we decrease the column by 1. If it's right, we increase the column by 1, right? And then let's say we have our current character is either equal to left or the right. So if current character is equal to left, so we increase the current direction by 1, right? In this case, if initially it's up, if I increase the current direction by 1, it will be left, right? So in this case, if I continue to increase the left or the current character or the current direction by 1, it will eventually exceed 3, right? So if the current direction exceeds 3, then we have to make sure, right? If the current direction is right, if I want to turn, or in this case, rotate 90 degrees to the left, it will be up, right? It will come back to up. And then same thing for the right. If current character is equal to right, I decrease the current direction by 1, right? If I'm at up, I will decrease the current direction by 1. Then I want to make sure if it's a -1 or less than 0, I want to make sure that current direction should point to right, right? So one is going to the normal direction, right? The other one is going to the opposite direction. And then at the end, just like I mentioned, we do our check to see if it satisfies those two conditions. If it doesn't, we just return false, right? So basically, you can see this is how we solve the problem. And the time complexity in this case is basically linear. Space complexity in this case is basically just going to be constant, right? So we're using just variables to keep track of all the values that we have.